All right, here's the last problem of the lesson, probably the most important problem that I want everybody to understand. And that's really just applying the idea of that perpendicular bisector of the chord in figuring out a distance here. And so if we read the problem, it says that Wx has a length of 8 units and that the length of the radius of the circle Z is 5 units. And so then it's saying how far from the center is the chord. And so they're looking for this distance right here. You can grab a line here. They're looking for this distance right here from that center to the chord. But what we know is, and I'm going to use a dotted line here, that if we folded this so that W and X lied on top of each other, we would end up getting a crease that is a perpendicular bisector here. All right, which means that if it's a perpendicular bisector, that Wx, that length of 8, is going to get cut perfectly in half. And so that this right here has a length of 4, and this right here has a length of 4. Not 45, of 4. Because it got cut perfectly in half by that perpendicular bisector. Well, we also know in the problem that this circle here has a radius of 5, and that can come help us out here. We grab a line here. From the center out to W, that would be a radius. Because W is on the edge of the circle, Z is the center. And we know that that has a length of 5. And so actually, we have a right triangle right here. Because of a perpendicular bisector, that forms a 90-degree angle. We have a length of 4 because it got cut in half from 8. And we have a radius of 5. So if I redraw a triangle here the best I can, you have this here where you have this is 5, this is 4, and then we have the missing side that we need to figure out, which is X. And you could use a Pythagorean triple. Maybe some of you see the Pythagorean triple and can figure out what X is right away. Otherwise, we have to use the Pythagorean theorem, and we have to say that X squared plus 4 squared equals 5 squared, because 5 is really our hypotenuse, and that's why it's the one that we set it equal to. And then when we work this out here, we end up getting x squared plus 16 equals 25. We subtract, I'll move it up to here, we subtract the 16 over, so we subtract 16 on this side, subtract it on the right side, and we're left with x squared equals 9. And then to get x by itself, we square root it to get rid of the squaring, square root both sides, and so x equals 3. X being 3, and that would be our answer for this problem. And this is really that problem that I want us, this is kind of the idea of the lesson, the proof problem, and the first part. It's really just to get the idea of the vocab and seeing that, like, hey, if we did fold these chords, we always get, a diameter or this perpendicular bisector, and that perpendicular bisector can help us. That's really the big idea here. And we see how it helps us right here. We know the length of Wx, and we know the radius, and with that, we were able to find some other measurements. And so this will just be the beginning idea here. As we go through chapter 10, we will be using this idea of a perpendicular bisector quite a bit. If you have any questions, please email me. Make sure you take a look at the math notes page here, because it has just good examples of minor arcs, major arcs, and a good recap of that vocabulary from this lesson.